Today we're going to be rigging this MECH character. The geometry and the meta rig are already set up for you if you just download the startup file in the description of the video. Then you can follow along with me as we go through the tutorial. Hello, welcome to Node Spaghetti. Today we are going to be working on this MECH character, which has a bunch of cool features, so it's probably going to take multiple videos. You can see we've got an IKFK leg here, we've got an IKFK switch in the arms, and they also have this pretty cool aim constraint thing. And you can see that the parent is switchable. You can see what this does. Since it is, after all, a gigantic robot, we need to be able to control where it's aiming. What else? Oh, we've got this cool extra pivot point in the torso that we can put wherever we want. Got two of them, actually. And you can have as many of those as you want. Actually, it's just a node group that you can, it's in here somewhere. Right here, yeah. So if I wanted to add a third one, then all I'd have to do, move this guy over, Control-Shift-D to duplicate it with the inputs, move that in there, move that there, call it Torso 2, and now you've got a third one. That's the power of nodes, right? So that's a general overview of where we're at with this character. I might add I put these curves in it. I'd like to rig and animate those too at some point. But when I put all this together, I hadn't built all the features I needed, so maybe I'll be doing that live later in the demonstration. Anyhow, first we're going to look at the IKFK leg. So let me just delete this and start over. Let's call this one Demo MECH Rig. So the first thing we're going to need to do is set up our space. All of our geometry for the character is in this collection, this MECH collection up here. And you can see that the objects in our scene are named according to a overall pattern, right? And we're just naming them what they are. The objects and the meshes are all given the same name so that we can easily look them both up without having to add any extra nodes. And finally, we have a meta collection, which uses the same names for everything. And just because it's annoying to see all the names for the fingers and thumbs, which you can see follow a convention there, I'm just going to hide them just because they're annoying, but we'll need them later. Although I don't even think I'm going to get to the hand in the first video. It's probably going to be in the second or third. But that's the most important setup we need to do. And now let's go ahead and start the process of making an IKFK leg. All right, so let's go ahead and add ourselves an armature node, and we'll call it MECH in the name box. And we're going to want to add a bone. We're going to be doing an IKFK leg, so we'll just do the thigh bone, thigh.l. We need to make it a child of the armature with an inherit node. That will give it an armature to connect to. Let's go ahead and add a meta rig node. See, now we have our MECH object with one bone in it. Actually, one of the things that's kind of neat is that you can, if you want to, you can use the bone itself as its own meta rig bone. And of course, when you regenerate it, it will stay where you put it, as long as you do the changes in edit mode. Now, we don't actually want to do that. I just wanted to show it because it might be a nice workflow. I don't know. I haven't tried it yet, to be honest. This next one's going to be shin.l. And at this point, since we're going to be doing a switching IKFK rig, we need to duplicate this, duplicate it, and duplicate it. This one will be our FK chain. Then we need to add a prefix here, just to make sure we know that it's an FK bone. I got it well. And there too. And we'll do the same thing on this one. We'll do MECH IK underscore, whatchamacallit, I.L. Call that control. No, this is a switch. So we will call it, maybe we can call it switch thigh.l. And then on top of everything, we're going to have a parent. So we'll call this one PRNT-leg.l. And all of these will be a child of this parent bone. And let's make all of them inherit rotation. And for the parent, I like to just make sure it's a slightly different shape than the thigh bone so that I can select it more easily. And in order to do that, I like to set its length to something smaller, like 0.25 will work. Now if I go into X-ray mode, you can see the parent is this little one. Something else you can do is just start making custom shapes for it. I'll make a mesh. I like to make a gear shape for these. So check as you select. Call this one widget gear. And I already had one in my widget collection, actually. I'll just use the one I already had. So in order to make this an IKFK switching leg, we need to add some constraints. We're going to use copy transform constraints. We're going to name them FK for the first one and then IK for the second one. And actually, the name that you put in the top of the node there, on the constraints, it actually names the constraint when we generate it. So if we select this switch thigh.l, this bone right here, right? Then our constraints here has an FK and an IK constraint. See that? And they're both copy transforms. Obviously, we're going to need to add some targets. And by the way, in the future, if you generate them without having a target, I think I'm going to have it automatically remove them or just not generate them in the first place. I guess I'm willing to have some feedback about that because I don't really see the point of generating it at all if it has no target. And it allows for a little bit more flexibility in this system. Since you can supply the targets with a node group, so if you just don't give it a target, you can prevent it from getting generated at all. I don't know. We'll see, right? Anyhow, now, if we just take our FK bones, we want to unlock their rotation. Our switch can be set to IK by turning these on. See that? Oh, and by the way, I like to set the FK bones to be connected, so let's connect them. And now you can see that they are, in fact, connected. See that? So we need to add an IK constraint to our IK leg called inverse kinematics. It needs a target. So let's go ahead and add another bone to our tree, and we will use the shin as our meta bone, but we need to place the bone right there, right? So what we can do is we can get a point from a bone matrix, plonk that in there, grab the tail, and now we can set matrix location. And if we don't plug a matrix in there, it will just use an identity matrix, if you know what that is. We should probably call this MECH IK target leg.L. And we can plug that into the target of our IK constraint. For now, let's unlock its transforms. And oh, it's not doing anything because we have to set influence, position, chain length, and use tail. I should probably make those defaults. I just haven't done defaults on everything because there are like 100 nodes and it would take enough time that it would be annoying to do. So we've already got the basics of our IKFK leg. All that's left to do is add a whole bunch of stuff to name it automatically. In order to do that, we're going to need to make this into a group. So what I like to do is I like to have the parent and the whatever the parent is of the IK handle and a separate input. So let's Control G to make a group. Sometimes it gets screwed up when there's these panels. Let's see. So this first one is the IK handle parent, and the second one is the leg parent. Very good. Now let's add some concatenate strings nodes. Then we'll just copy this, erase the .l. We'll put a .l there. At this point, I think I will have them all use the same metarig node because I don't want to deal with that. So I'll just go ahead, make another one of these, thigh, in that slot. There we go. And I'll do that for all the rest of them. So I want to show off a new feature that I added recently, which makes this next part at least a lot easier. If you select a concatenate string node, you can press F3 and select nodes of same type as active. And you can see this will select all of our concatenate string nodes. And now let's go ahead and add a chiral ID to the tree so that we can do the next step. Select nodes of same type as active. And now we can connect socket to input for selected nodes. So our node group input is going to be chiral ID and our node input is string 2. And now we press OK and look what just happened. There is now a node group input for every single one of those nodes that connects the chiral ID into the second string port. Really cool, right? Of course it is. So now we can leave this. For now, we'll just plug them directly into the armature and we'll set the chiral ID to L and R, .L and .R, generate. And you can see we've already got the beginnings of an IKFK leg component group. Awesome. Oh, by the way, I want to connect something into the influence of these guys because we're going to add a driver. And let's call this IK influence driver. Now, obviously we don't have a driver in there right now, but we can add an IKFK switch here. Whoops. I like it to default to FK being turned off. Whether to use FK or IK. Add a switch node and just plug that in there. And of course, we should probably have a separate parent for the right. Oh, by the way, I like to set IK to default to on for a leg controller. So at this point, we have our IKFK limb, and we can switch it back and forth with this controller. Let's go ahead and quickly set a name for this node group. IKFK limb. I'm calling it limb because it can work just as well for the arm or for the leg, since we've separated all of the unique behavior in the foot into this IK handle parent input. So if I add a bone and an inherit node, and check this out. I've added in between the sessions of recording this some new user interface code. So now if there's a problem in the tree, it will give you a pop-up and select the node. And even better, if the node is nested in a node group somewhere, it will select the node group and select the node inside the node group. It also also does a few other things that are really nice for the user interface. For example, it won't leave you in edit mode anymore if it fails to build the tree. It'll go back to object mode even when it encounters an error. And that was causing me some stability problems and some undo problems. So just goes to show that support you're giving me is very helpful. Let's call this one control ik foot.l, and let's add a group out. Let's name the input parent and the output foot control. And I think I will also go ahead and just set up a right-left chiral identifier thing here. Chiral ID. So we can just plug that into the ik handle parent. And now if we unlock its transforms, you can see that we can move the leg as if this was a foot controller. Now obviously a foot controller needs to have some features and it needs to be in the right place. Over here I have prepared a Rigify snippet of just the foot controller so that you can see the features it needs to have. You can see that we can move the foot left and right and forward and backwards in this rocking motion. And we can also pivot it from the toe. There is an IKFK switch here. And finally there's an overall location controller. And obviously I've removed the rest of the rig, so it's just the parts we need, but it's still 24 bones and probably 50 constraints. And in fact, there's a way to generate a tree from a given object, and it doesn't always work, especially since I chopped a whole bunch of pieces off of this rig. But I mean, even what it succeeded at making is it's super complex, right? So we're not going to try to do that. I've come up with a much more simple solution to this problem that hits all the same notes, but it's a lot easier to understand and set up. So at this point, we've got our parent for our IK leg that we can use as a foot controller. And what we want is an IK heel rocking controller. Let's talk through how we're going to do this. So if I take this pivot point here for the IK handle and I put it there, you can see that it rotates from that location. If I put it there, it rotates from that location. If I put it there from the back, if I put it there, it's from the front. The problem is that if I move it to a new pivot point location, the foot obviously follows. What we need some way to get rid of that motion, but keep the pivot point. So I'm just going to place it in the center there, and I'm going to duplicate the bone, and I'm going to make this other bone smaller, and I'm going to make it a child of the original bone, and I'm going to make the IK handle a child of this new bone that I just made, the small one, so you can see what that does. Now obviously this doesn't really solve our problem because we still have the foot following the pivot point, but if we take the secondary bone that's in between them, the socket, if you will, and move it back, then we can use this as our pivot point. So move the pivot point, take this and move it back, and then rotate the pivot point, and it just works. So the way we can do this automatically is with a copy location constraint with the axes inverted, and of course we have to do it in local space so that it references the original location of the bone. And now we can move this pivot point around to any location we desire, and it sort of just works. It has all the advantages of the other way of doing things with lots and lots of bones, but we only have 2 bones and 1 constraint. Super simple, right? Now it gets a little bit more complicated when we want to set up a heel controller to move this guy around automatically. But as you're going to see, it's really not that hard. And it only requires, I think, 2 or 3 constraints. So let's dive into our node group. Let's go ahead and name it IK foot roll. So the first thing we're going to need to do is we're going to need to make a bone for our heel controller. Since we're going to need that in a second, we'll just call it control IK heel. We'll add our chiral ID in there. I think we want it to inherit all this stuff. We definitely don't want it to be connected. And we want the heel controller to show up probably right there. I think we might want the foot controller to go there also. So let's make a metarig node. We will choose the MECH. We grab the shin.l and we will, so, you know, if we plug in there, then you can see it goes directly to where the shin bone is. We don't want that. We want it to go to the end of the shin bone. So we will set an empty matrix location to a point at the end of this shin bone. And you can see that if we have a point from bone matrix, plug it into a set matrix location, and then plug that into both bones, now they end up going where we want them. At this point, I think I'll go back into our IKFK limb. I want to make this IK handle bone here. I want to make it shorter. So let's just set the bone matrix length, and obviously 0 isn't going to work. It'll cause an error if we do that. So we'll set it to that amount. And you can see by comparing the left and the right that our IK handle is now a lot smaller and therefore a lot more easy to ignore because it's going to get in our way while we're setting up this foot controller. Let's go ahead and plug our chiral ID thing into this metarig so that we can choose the left or the right. And you'll notice that it messes things up when we can't pick a bone because we don't have the chiral ID. That really confused me on my first attempt at recording this. So if it stops working and it puts it in a weird place, just double check that you've got all of the inputs in your node group. Very cool. Now the next thing we need to do is we need to place the pivot point between all of these toe meta rig bones, which can't be exactly below the foot because the foot's not centered, and we need it to be centered between all of these meta rig bones. If I make this selectable, we need to place it right there. And since we have all of the bones, we don't really want to go ahead and add a meta rig bone to that unless we're being lazy, which, there's no harm in being lazy. But we have all the information we need right here to just calculate it directly. And if you get comfortable doing these direct calculations, you can make some pretty complex rigs with a very simple input. So we're going to do the same thing we did before and set the matrix location directly with a location vector. Let's go ahead and add our bone to the tree. We're going to call it MECH IK underscore foot underscore pivot. And of course, it needs to be a child of the foot controller. And we can reuse the same inherit node. We don't need it twice. We'll plug this matrix in there. And we're going to add a new node group input called location. And now if I generate this, it'll be placed, right in the center of the armature. And if I move this location, well, obviously 532 is not good. If I set it to 2, if I set that to 2, I set that to 2, you can see what that does, right? We can directly set the location of the bone this way. And just because I might use this in a totally different rig, since I'm making a component that I want to be really easy to reuse, I'm going to go ahead and not do all the math inside the node group. Because the math might change based on what our specific meta rig setup is, right? In this case, we've got 4 toe bones for each foot. So we're going to go ahead and use them. Toe left.l, toe right.l. And we can point from bone matrix. Hopefully by this point, you're starting to see the power of some of the advanced rigging features that we have here. See, we can slide the bone that gets created along the meta bone. Also, isn't it nice how it's fast enough to just do live like this? That took a lot of work, and I'm always looking for new ways to make it even faster. Obviously, your support is appreciated because it will help me to make the tool even better. What we want to do is place it horizontally in the center of these 2 bones. So let's go ahead and set, let's do a vector math node, static vector math. It's called static vector math because it happens before the rig is generated, as opposed to happening live in pose mode. Blender doesn't have a very good interface for directly setting matrices with math yet. And while I could probably hack one together with Python, I haven't done it yet. I'm going to do it eventually. But right now we can only run the math before the tree starts. Anyhow, we're going to choose linear interpolation. And if I press E and show you what happens when we run this, well, we need it to stay between 0 and 1. One of these days, I'm going to figure out exactly how to make it so that the range of these float dialog boxes is reasonable. But you can see what it does if we go between 0 and 1. And if we switch to 0.5, then that's what we like, right? Very good. Now we're going to just duplicate this, and on this side, we're going to use the front and the rear toe. And you can see what this does. And finally, we could just mix between them to give ourselves a nice center point. And that's almost the same as either extreme, but it is a little bit different. So that's good. Go ahead and name this foot pivot location. And at this point, maybe you're starting to see that we have a larger structure forming. This is our left side, and all of this is going to be our right side once we're done with this larger structure. But this larger structure has some node groups that are made out of components. I like to name things for clarity's sake. I'll probably make it so that the node tree keeps track of this stuff and names it for you automatically, the labels on the nodes at some point. Always so much to do in so little time. Anyhow, we have our pivot point bone, and of course our counter pivot bone is the same in every way except that it's a child of the pivot. That error message is a little bit annoying. I'm going to have to, I'll workshop that a little bit, figure out the best way to do it. Anyhow, we'll call this one counter pivot. Uses the same location and matrix. All that stuff is fine. But it needs to have a copy location constraint. Let's go ahead and plug the parent in as the target, set the influence to 1, local space, turn on all the axes and invert all of them. And I like to turn on offset also. Oh, and let's go ahead and set the matrix length here, 0.1, and we'll do the same thing over here with our pivot and make it 0.05, I guess. Now we can move the pivot around and the counter pivot stays in place. Why isn't that copying? Oh, I did them backwards. There we go. Now we can plug this counter pivot out to our foot control because we want it to be the parent of our IK handle. See that? All right, we're most of the way done with this. Now at this point, I think I will actually move this foot parent out of the node group and make it be the parent, because I think I'm going to want to access it later. Just that in there. I'll call this one IK foot control. Then that can just grab the parent. And in fact, since that's in the same location as the parent, we can use a xform, a matrix of xform node, grab that from the parent and use that there. So we've just simplified things inside of our heel controller so that it only has the things it needs. There we go. Very cool. Now I've got a widget for the foot that I'm going to use here, which is called, widget foot. That way we can tell the difference between the foot and the heel controller. And again, I hope you're starting to see a larger structure form over here. Let's go ahead and finish up our heel controller by setting up the constraints that are going to make the pivot move to the right place when we move the heel. So at this point, let's look at a few ways we can have this pivot move forward and backwards based on the rotation of this guy. And in the first place, I think we should just go ahead and add a copy rotation constraint so that it rotates with it. And now we want this to move forward when this guy is rotated positively on its x-axis. See that here? We can do that with a driver. And if we just set it to the location we want it to be at, we can see that's its y-axis, negative y-axis. So we can add a driver to this, use that number. Our variable will be our heel controller. We want its x rotation in local space. And so we want it to be negative 0.548 if a greater than 0. Otherwise, we want it to be positive 0.548. Cool. So you can see what that does. Looks like I did it on the counter pivot on accident. So let me just copy the driver, delete it, paste the driver here, and that also shouldn't have the copy rotation. There we go. Now you can see what it does. Very cool. So we can do the same thing on the x-axis. Paste driver. You want the, the negative y to go negative x. If I can just find our pivot point, there we go. Delete the drivers on that and put it there. Oh no, I wanted to delete the single driver. Put it there. Add a driver. If a is less than 0, else positive 539. MECH. Heel control. We're going to use the Y rotation this time in local space. Let's see, YXC Euler. Update dependencies. And that doesn't seem to be doing anything. Let's find out why. I didn't rename the variable, that's why. So now you can see that it works and it chooses the pivot point correctly. Very cool. And this is a fine way of doing things, but you can also run into a problem where you can't move the pivot point if you want to. And I don't know if there's any reason why you would ever want to, but maybe an animator would want to for some reason. So I just like to give them that power if I can. And the way that you can do this without drivers, you can go ahead and delete them and do a transformation constraint. Now, a transformation constraint is the same thing as a driver, except it's a lot more flexible because it doesn't modify the transform properties of the object. And it has some of the nice features of a constraint that drivers don't have. I'm not going to explain it right now, but trust me that you can use this almost any place you would want to use a driver that affects your location, rotation, or scale, and it's always better to do so. And then we'll just set up exactly the same thing we just did. So on the x-axis, it goes to negative 0.55, I think, or positive 0.55. If the y-axis of the rotation is negative or positive. And we want our y-axis to do the same thing, approximately, if the x-axis of the controller moves positive or negative. So we'll change that to x. And it looks like we have the x-axis backwards on here. We needed to go to inverted axes. And it just works. So we end up having a fully functional heel rock rig with 3 bones and 1, 2, 3 constraints. Incredibly simple and super easy. And it's a lot easier to set this up with nodes because you can calculate all of these numbers directly with matrices and vectors and stuff. So you can reuse it again and again without having to think through it every time. So let's go ahead and do that in our node graph real quickly. We are going to add our copy rotation constraint right here. Make that the target. Influence all the way to 1, turn on all the axes, and you know what? I'd like it if I could also rotate the pivot separately to its copy rotation. Wouldn't you like that? I think I'd like that. So if I set that to before original, it looks like I can. So let's set the mix mode to before original. And now let's go ahead and set our transformation constraint, which goes onto our counter pivot bone. So transformation, plunk that in there, set it to local space. We want to map from rotation to location, and let's turn on the influence. Target is going to be our heel controller. Plug that in there. And now we need to do some math to figure out the axes here. So I'm just going to go right ahead and add a couple math nodes to figure something out. So we want to know, right now it's exactly in the center. So we want to know how far to move it to get it to the toe bone. And it should be exactly half of the total width or length of the foot. So in order to find out the width or length of the foot, we can add another vector math node, plug in our left and right toe bones, and we're just going to get the length of that vector. And we'll do the same thing with our front and back toe bones. Oh, we need to subtract the vector so that we can get the length of the resulting vector, of course. And we're gonna plug those in here as node group inputs. We do a static float math and multiply them by 0.5, and that's going to be our foot width and our foot length. Let's see, we also need to have the negative values of this. So let's have 1 multiply them by negative 0.5 also. And then our width, let's remember, our width is the x-axis, which is controlled by the y rotation of the heel controller. So y, we're going to go with negative to positive width. And if this all feels a little bit abstract, then let me know, because I want to make the tutorial fast, and I also want to avoid dumbing it down too much. But I also know that this stuff can be a little confusing, so make sure to leave a comment if I'm losing you at any point. So we want to move it forward on the y-axis, which is negative y, and backward on the y-axis, depending on the x, positive x and negative x rotation of the bone. So we'll do that. We want to put the negative y in the max and the positive y in the min. Press E to generate, and something seems to be going wrong. Where did they go? Turn the influence off and see where those bones went. Where's the counter pivot? Well, now I'm very confused. Let me disable this entirely. Got our foot pivot. I don't see our counter pivot bone. It isn't there at all. Oh, you know why? Because we didn't have the plugs connected. I wonder why it wasn't notifying me. I probably need to work on that. Anyhow, now you can see that we have, if we just turn this back on and set the influence up, we have our mostly functional rig, except I've done everything backwards. So let's just swap the orders of these maxes and mins. And again, it doesn't seem like it's working at all, but it is going to the right places. It's just going to the right places at the wrong times. I see what the problem is. It's moving the counter pivot instead of the pivot. Fortunately, with rigging nodes, this sort of thing is really easy. You can move the entire constraint by simply reattaching the relationship and just moving this guy over to here. Look at that. Totally by accident, I've shown you one of the really killer features of my add-on. Who could have seen that coming? And now you can see it's working like a charm. So check this out. We have just made a complete heel roll rig based on the concept of a movable pivot using just 3 bones and count them 1, 2, 3 constraints. If that's not as simple as it gets, I don't know what is. And of course there is a little bit of math involved, but I think all the math is simple enough that those of you who are watching the video at 2 times speed will be able to understand exactly what happened there. At this point, we've got our IK heel controller finished, and the next thing we need to do is we need to add the toes and the FK foot. And then we'll be completely done with this IKFK leg, along with all of its advanced features, except for using a pole vector constraint and like a soft IK, which we will do in a future tutorial, because I don't want this one to be too long. So the next thing we need to do is add the bones for the FK foot and for the toe bones. And just because I want it to be kind of simple, what I want to have is a bone that's like right there. And since we don't have a meta bone for that, what we're going to do is we're going to copy this toe front.l, and we're just going to set its location to where the cursor is now. But before we do anything, we need to get a bone for this. You'll notice that it's not popping up with errors at annoying times right now, and that's because I went back in and I updated my update, and now it only gives us the error when we press the E key to generate the graph manually. So it's just better. Cool, right? Anyhow, let's name this ik_foot.l. Let's make this the ik handle parent, and we're going to use the toe front bone. We're going to set the location of this matrix to the end of the shin, just like that. And now we just need to set the tail of the bone to the head of the toe front. You can see what that does. At this point, I want to mention that there's a significant limitation in the matrix math nodes right now, and that we can't directly calculate the bone roll, which is also why I use this particular bone as the basis, because the axes end up being the same as the original bone. We just don't have direct control over the bone roll right now, and it's because it's going to involve porting a whole bunch of matrix math from the C code to the Python code. It's not hard, it's just busy work. Now that we have our IK foot, we can go ahead and make an FK foot. We're going to use the matrix from our IK handle parent for the FK foot. So we're going to get the matrix of X form, and that works. Super easy. Now we're going to do the same thing with our switch. Change the name. Needs to have its FK and its IK copy transforms. From the FK foot, we copy transforms in the FK one, and we're going to grab the IK handle parent. We're going to use the IK influence driver for the IK constraint. And now, if we want to, we can switch between IK and FK, including the foot. Let's go ahead and plug some of these switch bones into an output. I, shin, and foot. Now we can add our toe bones. And I'm just going to grab these matrices because they're going to come in handy, right? So let's go ahead and add a few times. Very nice. At this point, just because it's kind of nice to feel the payoff, let's go ahead and add some objects in so we can see our character. For this purpose, I've added a new node. If we go to our transform menu, there's a new node called object instance. What you can do with this is you can bring in an existing object from the tree as a new instance. You can set up whatever kind of relationship you want, whatever matrix you want to give it. In this case, we're going to copy the original. And of course, it needs to have a name. And you can see that that will bring in our object. And if we look at the modifier panel, it's just a single modifier. If we go into edit mode, you can see there is nothing we can select because there's nothing there. And this is a very simple geometry nodes graph with exactly one node in it that it will generate. And the reason we're doing it this way, as opposed to some other way, is because this keeps all the modifiers and stuff as they are. And it's what we want for a hard surface model, since it keeps, you know, whatever it's got auto smoothing and it probably has a bevel modifier and all that. And you can see that it's being kept. So anyhow, let's just go ahead and add one more node to this, and that will be enough. That'll be enough for us to make this into a node group. Let's just make that a string. And for some reason, it grabbed two strings instead of just one. Call that name. We'll call the X form the parent. Let's move that down. Nice. And I think that's pretty straightforward. Oh, let's name this group add object instance. That way we can tell what it is. All right. So I'm just going to fill in all of the objects. The names of the objects, of course, are very sensible. They're the same as the names of the bones in this case. Of course, you can name them whatever you want. So at this point, we've got a few things we need to polish up. Our heel control is not moving the toes, as you can see, and our knee joint should really stay locked in the x-axis. Now that one at least is easy to solve. If we go into our IKFK limb, you can see the IK controls are exposed on this, and they really should be exposed on the thigh bone here also, because it is in the IK chain. And I've actually solved the problem of doing that in the past, but it was kind of slow, so I turned it off. If you need to access that, you can press Ctrl-H to unhide everything. Press Ctrl-H to hide it again. Or you can press E to generate the tree and it'll hide it automatically. Anyhow, we just need to check limit Y and limit Z so that only X is not limited. See, now it's doing what we want. And our heel controller is going to need to control the toe rotation so that they stay in the right shape as if they're on the ground. And I guess I need to just unlock their rotation so I can figure this out. And since we're going to want to animate this anyways, right? Because the animator should have control over these. So it looks like if we move our heel controller positive X, then we want to move our toe controller negative X, or rotate it. Let's add a transformation constraint to do this, just like we did with the pivot point earlier. And we're going to use the local space. You can see this one is the front toe. Let's see. We need the target to be the heel controller. So let's make that an output from our IK foot node. And I want to put that above the foot control. And I'll call it heel controller. And I think I'm just going to call this foot IK parent. There we go. Let's take that out and make that our target. And we'll choose to map from rotation to rotation. And we want to map from positive to negative, right? So it ends up being like this. Turn on the influence. Am I wrong? I might be wrong. Oh, yeah, we need the max 2 to be a negative number. And the way I know that is I just fiddle with it. You just mess with it until you figure it out. The reason I chose the number pi is because pi ends up being 180 degrees in radians. We want to do something similar here with the heel controller and the toe on the back. So if we just copy it, then it doesn't do what we want. We need to change some of these numbers around. And in fact, what we want is to, again, just because I've done this already and I know what the values are, we want to map it from a negative number to a negative number. And you can see that works real well. And again, it's kind of hard to figure out. You just have to fiddle with it. That's all there is to it. I've done enough fiddling with it that I know what numbers to put in there. But if you're doing this, you're going to need to fiddle with it yourself. Now for the side to side motion, we're going to need to map the Y rotation of the control. So let's go from Y to X, and not sure which numbers to use here. So we're just going to figure it out. All right, let's see if this works. Hey, that just worked. I didn't even think that would work. That's cool. Awesome. So we can just go ahead and hide the sockets we don't need there. And now all of the polish that we need to do on this is setting up custom objects and putting drivers in there to hide or unhide the controllers based on whether they're IK or FK. So I'm going to go ahead and walk you through adding the drivers to hide and unhide IK FK bones, but I'm not going to do that with the custom objects because that's just going to take too long. It's easy. You just add an object, you type in its name, and you plug it into the bone. So you don't need to see me do that again and again and again. I'm gonna do it off camera. So first, let's hide the bones we don't need to see by clicking on the hide checkbox at the bottom of the node. Everything in the switch chain, the IK shin and the IK handle, the rest of these we do want to be able to see. We want to be able to rotate the Y axis of our IK thigh so that we can do this. And we only want this to be visible when IK is turned on. So let's hook a driver up to the hide socket of the bone so we can control when it's visible. Now, if we use our IK influence driver, you can see that that's it's backwards. So actually what we need to do is we need to have an inverted driver. And unfortunately, the best way to do that right now is to just bring in another switch with invert switch. And we can just duplicate this input and change the name a little bit. Now if we press E to generate it, you can see that bone disappears when FK is enabled. So let's go ahead and put the IK influence driver on the FK bones also. And that's nice. Oh, there's one last thing I want to be able to do, which is what I want to do with the transformation constraint is I think I want it to mix before the original. That's just my preference. Let's just do that. These nodes get unreasonably large. Press E to generate the tree and it will hide the ones you don't need. It's context sensitive based on what menus you've selected and stuff, so it has to hide and unhide sockets. Not all of them are used all the time. Once I add all the custom objects to this, it will be pretty much polished up and ready to use. And then all we're going to have to do is add the names to things. So I'm going to go ahead and add the custom objects, and I'll just zoom through it. And then I'm going to come back and I'm going to add the concatenate string nodes as needed. Okay, I've done it, and gone ahead and added the hide and show driver to a few more things, and I've added shapes to some things, and it's pretty much 100% good to go. There's one more detail that we need to address, which is it'd be nice if this could have a parent switch, but we're not going to do that until our rig is a little bit more complete, because it doesn't have a body for it to do any parent switching with. So we're just going to leave it how it is for now. And that is our IKFK leg. So all that's left to do is make it into a reusable group, and I'll go ahead and do that again off camera, and then we'll be able to put the right leg together very easily. And there it is. Just had to connect some stuff together and do a little bit of pretty simple renaming of things and got ourselves a right and a left leg. Oh shoot, I need to make sure this defaults to IK turned on, obviously. And because I'm a genius, everything just works except for the toes here seems to have some problems. And the reason it has some problems is because in the first place, I'm not 100% sure that I did all this correctly. There we go. I need to grab these nodes and use these meta rigs with the switch, chiral identifier switch. And you'll notice that it works, but you'll also notice something that I've been hiding from you this whole time, which is that our meta rig here It's actually not quite symmetrical. You can see that I have, if I were to symmetrize these bones, see what it does? Puts the right toe on the inside, the left toe on the outside. So the thing is, if it were to do that, then I would have to go in here and flip something in the transform constraint, and that's kind of a pain to do right now. I'm going to show you how to do that in a later video. But for now, it's kind of easier to just have a very small asymmetry in our meta rig. So that's the way I opted to solve this problem. And that is basically the lower half of our mech. Pretty great, isn't it? And the cool thing is we can use this on any character. First of all, any character that has legs can use everything but these 3 extra toes, right? And that's, I mean, it's as easy as just getting rid of the ones you don't need, right? If I were to do that, regenerate the graph, now it's got regular human feet. See that? I don't want to delete those. I like them. Now it's got mech feet again. But, everything here is totally reusable on any character. And there are, there's some things you've got to consider if you are trying to make it a reusable component pack like the one that I have published that I didn't bother to do here. But for most of your projects, this is going to be 100% enough. Yeah, I hope this has been very helpful. Mantis Trading Nodes is made possible with your generous support. You can support me monthly on Locals. I'll probably make a Patreon soon. And you can buy my products on Gumroad, the component pack, or the textures. Locals members, and when I make a Patreon members will have access to these exclusive password-protected downloads, the component pack, texture packs as I make them available, and the finished mech rig, which we're going to be making by the end of this tutorial series, which should have 1 or maybe 2 more videos. And that's a wrap. Go ahead and leave a comment about what your favorite mecha is, whether it's something from Asia, like Mobile Suit Gundam, or something a little bit more modern, like, I don't know, Pacific Rim, or maybe it's something from the 80s and 90s, like, pretty sure that's when Battletech was most popular. That's what I like, and I think it's obvious by the mech that I designed. And maybe leave a comment about the other things that you'd like me to design rigs for and show off and make videos about. A little bit of the future of the channel. I'm going to be moving house, so it might take me an extra week to make the next video. And in the future, I'd also like to be making stuff regarding geometry nodes and maybe a little bit of game design stuff. These mechs, for example, would be perfect for a little Godot strategy game that I'm thinking about making. So stay tuned, and thank you for your generous support and for your attention. I really appreciate the feedback and all the kind words I've gotten.